AH-1Z Viper 4 is an American twin-engine attack helicopter based on the AH-1W Super Cobra that was developed for the United States Marine Corps as part of the AH-1 upgrade program. The AH-1Z features a four-blade, bearingless, composite main rotor system, uprated transmission, and a new target sighting system. 5 The AH-1Z, one of the latest members of the prolific Huey family, is also called Zulu Cobra, based on the military phonetic alphabet pronunciation of its variant letter. Aspects of the AH-1Z date back to the Bell 249 in 1979, which was basically an AH-1S equipped with the four-blade main rotor system from the Bell 412. This helicopter demonstrated Bell's Cobra 2 design at the Farnborough Air Show in 1980. The Cobra 2 was to be equipped with Hellfire missiles, a new targeting system and improved engines. Later came the Cobra 2000 proposal, which included General Electric T700 engines and a four-blade rotor. This design drew interest from the U.S. Marine Corps, but funding was not available. In 1993, Bell proposed an AH-1W-based version for the UK's new attack helicopter program. The derivative design, named Cobra Venom, featured a modern digital cockpit and could carry tools, Hellfire or Brimstone missiles. The Cobra Venom design was altered in 1995 by changing to a four-blade rotor system. The design lost to the AH-64D later that year, however. The use launched the AH-1 upgrade program by signing a contract with Bell Helicopter for upgrading 180 AH-1Ws into AH-1Zs and upgrading 101 nanosecond into UH-1Ys. 67 The AH-1 program created completely modernized attack and utility helicopters with considerable design commonality to reduce operating costs. The AH-1Z and AH-1Y share a common tail boom, engines, rotor system, drive brain, avionics architecture, software, controls and displays for over 84% identical components. 8. Bell participated in a joint Bell government integrated test team during the engineering, manufacturing, development phase of the AH-1 program. The AH-1Z program progressed slowly from 1996 to 2003 largely as a research and development operation. The existing two-blade semi-rigid, teetering rotor system is being replaced with a four-blade, hingeless, bearingless rotor system. The four-blade configuration provides improvements in flight characteristics including increased flight envelope, maximum speed, vertical rate of climb, payload and reduced rotor vibration level. The AH-1Z first flew on the 8th of December 2000. Bell delivered 3 prototype aircraft to the United States Navy's Naval Air Systems Command Navarre Naval Air Station Patuxent River in July 2002 for the flight test phase of the program. Low-rate initial production began in October 2003 with deliveries to run through 2018. In late 2006, Navarre awarded a contract to Mega Defense Systems to develop a new linkless 20mm ammunition handling system to improve on the gun feed reliability of the existing link feed system. These systems are now being retrofitted into the AH-1W and AH-1Z fleets with good results during combat in Afghanistan. In February 2008, the U.S. Navy adjusted the contract so the last 40 AH-1Zs are built as new airframes instead of the previously planned rebuild of AH-1Ws. In September 2008, the Navy requested an additional 46 airframes for the Marine Corps, bringing the total number ordered to 226. In 2010, the Marine Corps planned to order 189 AH-1Zs with 58 of them being new airframes, with deliveries to continue until 2022. On the 10th of December 2010, the Department of the Navy approved the AH-1Z for full-rate production. The AH-1Z incorporates new rotor technology with upgraded military avionics, weapons systems, and electro-optical sensors in an integrated weapons platform. It has improved survivability and can find targets at longer ranges and attack them with precision weapons. 8. The AH-1Z's new bearingless, hingeless rotor system has 75% fewer parts than that of four-bladed articulated systems. The blades are made of composites, which have an increased ballistic survivability. And there is a semi-automatic folding system for storage aboard amphibious assault ships. 8. Its two redesigned wing stubs are longer, with each adding a wingtip station for a missile such as the AIM-9 Sidewinder. Each wing has two other stations for 2.75-inch 70mm Hydra 70 rocket pods, or AH-114 Hellfire quad missile launchers. The AIM/AH-78 longbow fire control radar can also be mounted on the wingtip station. The model's integrated avionics system has been developed by Northrop Grumman. The system includes two mission computers and an automatic flight control system. Each crew station has two 8x6-inch multifunction liquid crystal displays LCD and one 4.2x4.2-inch dual-function LCD. The communication suite combines US Navy Route 1824 integrated radio, UF/VHF, COMSEC and modem in a single unit. The navigation suite includes an embedded GPS inertial navigation system, e.g., a digital map system and megabits low airspeed air data subsystem, which allows weapons delivery when hovering. The crew are equipped with the full Top Owl helmet-mounted sight and display system. 5. The Top Owl has a 24-hour day/night capability and a binocular display with a 40 degrees field of view. Its visor projection provides forward-looking infrared FLIR, or video imagery. The AH-1Z has survivability equipment including the hover infrared suppression system HERS to cover engine exhausts, countermeasure dispensers, radar warning, incoming/on-way missile warning, and on-fuselage laser spot warning systems. The Lockheed Martin Target Sight System TSS incorporates a third-generation FLIR sensor. The TSS provides target sighting in day, night, or adverse weather conditions. The system has various view modes and can track with FLIR or by TV. The same system is also used on the KC-130J. U.S. Marine AH-1Z lands on USS Mackinac Island in 2010. The AH-1Z completed sea trial flight testing in May 2005. On the 15th of October 2005, used through the Naval Air Systems Command. Accepted delivery of the first AH-1Z production helicopter to enter the fleet. 2. The AH-1Z and A-1W completed their developmental testing in early 2006.22 during the first quarter of 2006. The aircraft were transferred to the operational test unit at the Nispatuxet River, where they began operational evaluation of pebble testing. 23. In February 2008,